Now, the last section of this chapter deals with compositions of transformations. And anytime we deal with a composition of transformations, it's actually just taking one transformation followed by another. For example, if we talk about a glide reflection, that's just taking a composition of a translation, so sliding, and a reflection, so a reflection across or a flipping across a line that would be parallel to our translation vector. Now, what we have here is an example of a glide reflection. And what they're doing is they're taking triangle JKL, and we're transforming that, or translating it and then reflecting it, to triangle J prime, K prime, L prime. And that would be a combination of both a translation along this vector V, followed by a reflection across the line L. So what we're going to do for the glide reflection is we're going to translate it first. So notice, if I'm going to translate it along vector V, I'm going to travel in this direction that amount. So here's J. It's going to travel in that direction that amount. Same thing with K. Same thing with L. So this is the first thing that happens is the translation. And then after that, we're going to go ahead and reflect it along the line L. And when you reflect it, it's the flip. So that means that this J becomes J prime down here. And this point becomes K prime down here, and lastly L becomes L prime down here. So it was a glide reflection because we translated it and then we flipped it. So that's a composition of transformations. So in this example, what I'm going to ask you to do is, on your own, you're going to first reflect our quadrilateral PQRS across line M, and then you're going to translate it along this vector V. So I'd like for you to reflect this across the line M, and then I want you to translate it. So go ahead and try to draw that out. Pause the video, do it on your own, and when you're all set and ready, start it up again, and I'll have my best possible diagram that I can draw on this. Give me a little leniency. All right, let's go ahead and discuss what I have drawn here. The first thing we did was reflect the quadrilateral along line M. So that's what I have here. P to P prime, S to S prime, R to R prime, and Q to Q prime. Next, after I've reflected it, I'm going to then translate it, and I did my best here. I'm going to translate it by the vector V. So I went from Q to Q prime to Q double prime, P prime to P double prime, S prime to S double prime, and R prime to R double prime. So hopefully you noticed it was a reflection and then a translation. You got something similar to what I have drawn. Doesn't have to be exactly perfect, but get it in the same ballpark. Now for this example, we're going to use specific vertices in the coordinate plane, and I'm going to ask you to do two things. First off, you're going to rotate your triangle 180 degrees about the origin, which you've done before, and then after you're done with that, you're going to go ahead and reflect it across the y-axis. So you're doing a composition of transformations. So I know that you know how to do the 180 degree about the origin. You even have it on a note card, hopefully, and that says that if you've got the point x comma y, the rule for rotating 180 degrees around the origin says that you're going to negate the x and you will negate the y. So the first thing I want you to do is I want you to do that. After you're done doing that rule, you're going to take those new points, so K prime, L prime, and M prime, and you're going to do the next transformation to it, and you're going to reflect it across the y-axis. So y-axis reflection is taking the points you have and doing a negative x, y to it. So go ahead. Make two columns here. Actually, let's go ahead and make three. I want you to write down the points K, L, and M. Then, with the initial points of K, L, and M, I want you to do the first transformation. I want you to find K prime, L prime, and M prime by doing our rotation of 180 degrees about the origin, and after you get what those are, I want you to then tell me what K double prime, L double prime, and M double prime are. You can also then, for me, because it says draw the result of the composition of isometries, I want you to draw out what K prime, L prime, M prime are, and then I want you to also draw out what you get for K double prime, L double prime, and M double prime, so you can see how you ended up changing your original triangle. So go ahead and do that. Pause the video here, and when you're all set and ready, start it up again, and I'll have all of those points written down along with the new diagrams. So taking a look, my K prime was negative 4, 1, L prime was negative 5, 2, and M prime was negative 1, 4. When I drew it out over here, it did indeed look like we took this and rotated 180 degrees around our origin. Then we did the reflection across the y-axis, so all we had to do was negate all of my x values. So the negative 4, 1 became 4, 1, negative 5, 2 became 5, 2, and negative 1, 4 became 1, 4. So I then plotted those, and of course it does indeed look like we took this triangle and reflected it across the y-axis. So our final figure is this one over here. Now I'm going to ask you to do this whole entire example on your own. What I'd like for you to do is you're going to go ahead and draw out J, K, and L, the triangle, on the graph that's given. And then you're going to reflect the triangle along the y-axis, and after you're done with that, you're going to rotate it 180 degrees around the origin. So I'm going to do the 3 columns again, J, K, L, J prime, K prime, L prime, and then J double prime, K double prime, L double prime. I want to see all those points. In addition, I want to see all 3 of the triangles at each of the steps. So the original one, the next one that occurs after you flip it across the y-axis, and then the last one for the rotation about the origin. I want to see all of that work shown. You're going to pause the video here. You're going to do it on your own. And when you're all set and ready, you're going to start the video up, and I'll have the answers written down for you and talk you through it. Okay, so let's go ahead and take a look at what I've got written. So the first transformation was across the y-axis. So my original triangle gets flipped across the y-axis, and that's how I get J prime of negative 1, negative 2, K prime of negative 4, negative 2, and L prime of negative 3, 0. Because of the rules, flipping across the y-axis meant we negated the x's and kept the y's the same. And then we rotated 180 degrees about the origin. So my rule said you're going to negate both the x and the y when you do a 180 degree revolution. So I took my J prime, K prime, and L prime and negated both the x and the y's. So by doing the revolution, I got J prime, double prime, to be 1, 2, K double prime to be 4, 2, and L double prime to be 3, 0. Hopefully that's what you ended up getting also. So the last thing we want to cover in this section are a couple theorems here. And the first theorem says that the composition of 2 reflections across 2 parallel lines, which we have here, is actually equivalent to just a translation. So if I were to take the blue figure and reflect it across the first line, I get the green figure. And then if I take the green figure and reflect it across the next line, which is parallel to the first, I'll get the red, which just happens to be just a translation. Now that translation vector that we end up utilizing will be perpendicular to 2 parallel lines, and we also know that the length of the translation vector will be twice the distance between those 2 parallel lines. So that's what you need to know. If you're dealing with 2 reflections across 2 parallel lines, you just have a translation. Now what happens if I take 2 reflections across 2 intersecting lines instead of parallel lines? So if I've got 2 lines that intersect and I do 2 reflections, so from the blue reflected to the green, and then if I took the green and reflected along the line to get the red, that's actually just going to be a rotation. So instead of it being 2 parallel lines and getting a translation, if they're 2 intersecting lines, you get a rotation. The center of rotation will actually be the intersection of those 2 lines, and the angle that we rotate will actually be the angle that's between my 2 lines that are intersecting, double that. So that's a good piece of information to know because we're going to utilize it in our last example. So in our last example here, it says that Sean reflects a design across line P, and then he reflects that image across line Q. And we notice that P and Q are both parallel lines, so 2 reflections across 2 parallel lines is equivalent to just a translation. So describe a single transformation that moves the design from the original position to the final position. And I just kind of said it. If you have 2 reflections across 2 parallel lines, it will just be a translation. So we're going to say it is a translation. And then the last thing I want to do is I want to be a little bit more specific and tell them a translation of what. And notice they are telling us the distance between our 2 parallel lines is 5 centimeters. And we said the length of the translation vector in this instance will be twice the distance between the 2 lines. So twice 5 centimeters is going to be 10 centimeters. So it is a translation of 10 centimeters. And we'll even be a little bit more specific and we'll say it's to the right. All right, so that was the last example. If you have any questions on anything that was presented in this lesson, please make sure you write them down and you ask your teacher in class. Have a good night.